Alright, so welcome to my lesson on topic 11. This is VP Interpolation. I'm Connor Gleason, and I am helped by the group Y. So, do you like interpolation? If you answered yes,
What? Did we just become best friends? Yup.
then that's awesome. But, if not, then maybe I'll teach you a little more about interpolation. So, what is interpolation? It's basically a way to make predictions from data sets. So basically, if you have 2 points and you want to find the point in between them, then that's why you interpolate. But didn't we just do this? No, not necessarily. Interpolation assumes that data points were exact values to create a relationship between 2 points. In topic 10, curve fitting, a relationship is fit to all of the data. So in this case, interpolation gives an exact point between the 2 other points, while curve fitting always took every single point in your graph into consideration. Wow, aren't those different? In case you didn't get it, it's also different. Trying to keep it creative here on the lighter side. So, let's move on. So now I'm going to move on to linear interpolation. For linear interpolation, you are given 2 points, x1, y1, and x2, y2. So we're trying to find an approximate y value for determined x value that we are given or trying to find. Now, but wait, make sure that your x value that you are determining is between x1 and x2. This means that your x must be within your bounds. Once you have that confirmed, then you use the equation for the slope of a line. This would be y minus y1 divided by x minus x2. That will give you the slope, and then you do y2 minus y1 equals x2 minus x1. That will give you the slope of the 2 lines. The first one gives you the slope of the interpolated value and the first dot. Now you set them equal to each other, so now you know that the slopes will be equal. Then you solve for y. Solving for y, you get y equals y1 plus x minus x1 over x2 minus x1 multiplied by y2 minus y1. So, but there's not just linear interpolation, there's also higher order interpolation. The 3 different types of higher order interpolation, I mean, there is linear, which I just explained. That's not necessarily higher order, but there's quadratic, cubic, and a spline. So we give linear so you have an idea of what you're basing it off of. So linear, your order is 1. Quadratic, your order is 2. And cubic, your order is 3. And that's just a MATLAB expression so you can differentiate between linear, quadratic, and cubic. Now, the equation for linear is y equals ax plus b. We all know that. So that means there are 2 parameters. So that also means that there are 2 points required to solve your system equations. And if we go back to the last slide, getting your y equals y1 in that equation. Now, for quadratic, it's slightly different. So now you have y equals ax squared plus bx plus c. Now you have 3 parameters, so there are 3 points required to solve for this. And that also means that there are 3 different equations for your system equations. And I would solve for y for you, but that's really, really complicated, and that's even more complicated with cubic, and that's why there's a computer, so the computer will do it for us. And now for cubic, the third order, you have the equation y equals ax cubed plus bx squared plus cx plus d. Now you can see there are 4 parameters, and there are 4 points required. So once again, it's very, very messy to get the 4 system of equations and solve it for y, and that's why we let the computer do it for us. And then there's window interpolation. This is for when you have multiple x values that you're trying to interpolate. So there's 3 steps to this. Step 1, finding the window. Finding the x1 and the x2 that are on either sides of your x value. So once again, make sure that your x is in between your x1 and your x2. Then you interpolate. Once you interpolate for that x value, and then you go to step 3, and you repeat this as many times as there are x values. And always making sure that your x is within your bounds. And remember that the x values, or the bounds that you are solving for the x values, have to be directly on either side of your x value. That means you can't have a point that's 3 points down on the right and 3 points down on the left. You always want a point that's directly to the right and directly to the left of your point. So, going to the MATLAB functions, there are two different interpolation MATLAB functions. The first one is polyfit. Now, it's pretty obvious that polyfit will give you an equation that will fit the data, not curve fitting though, that will fit the data, and they will give you an interpolated function that you can then graph. So, the inputs for polyfit, it goes, the first input is x, the second input is your y's, and your last input is your order numbers. So if we go back to the higher order interpolation, you can see the order numbers are 1, 2, and 3 for linear, quadratic, and cubic. Then, your outputs are the coefficients of an equation with a specific order number. So once again, if we go back to that slide of higher order interpolation, your outputs for, let's say for linear, would give you an A and a B. And then for quadratic, it would give an A, a B, and a C. And then you have to understand, after the order number you put in, that those are actually the coefficients to your equation. And then there's polyval, which actually will evaluate the interpolation for you. So your inputs for polyval are your polynomial, and your second will be the x values that you want to be interpolated. And then your outputs are your interpolated y values. So, for example, you put an equation in, and the equation doesn't necessarily state, let's say, 2. So you put your equation in, and you put 2 in, and then your output will be giving you a y. So, now that may have been a little bit confusing at first. So we're going to go through a couple of these equations on the actual MATLAB command window. So you pull up the command window, and let's type it in together here. So I'm going to be working out of page 464, chapter 14.1.3 in the MATLAB, A Practical Introduction to Programming book. So this is how we will do it. We'll type in x equals 2:6, and that will give you an array from 2 to 6. And then you're going to say y equals, and we're going to make this an array, square brackets, not curly brackets. And we're going to go 65 will be your first number, 67 will be your second number, then 72, 71, 63. Whoops, I'm sorry about that. Whoops. And then you enter that. And then what you're going to do is you're going to say your coefs, that's what you're going to set it to, because now you know that these are your coefficients of your equation that you're going to get. And then you go polyfit, and you're going to go x, comma y, comma 2. So what this is saying now is that your coefficients of your equation are between x and y, and it's going to be a quadratic equation because we put in order number 2. So you hit enter, and your coefficients are negative 1.85, 14.85, and 41.6. So if we put this into the equation, we're going to get y equals negative 1.8571x squared plus 14.8571x plus 41.6. And that's how the polyfit equation works. And now we're going to move on to the polyval equation. So for the polyval equation, we're going to type in curve equals polyval, and then we're going to do our equation, which is actually what we just did, coefs, and we're going to solve for the points in our x array. So we're going to solve for 2, 3, 4, 5, and 6. So that means we're going to get back 5 different points of the values of that equation, for the y values of that equation. So we hit enter, and now we see we're given back 5 equations, which is perfect. So we know that for the equation that we just found in the coefs, we know the answer for 2, 3, 4, 5, and 6. And that is how polyval works. And that is how MATLAB will interpolate for you. And so I hope you guys learned something today. Interpolating is not that hard, especially when you have polyfit and polyval, because MATLAB does all the work for you. So once again, thank you for watching, and have a nice day.